Okay, hello. All right, so today we're going to be talking about how to factor polynomials completely, okay? So what that means is that you're going to have to end up factoring some of the polynomials more than once. So you're going to be using more than just one method, more than just doing GCF or dots or trinomial, okay? So before we get into that, let's look at the do now. So we want to identify the type of factoring and factor it. So no matter what, you always start off by checking to see, is there a GCF? So that is always going to be your first step. So let me just zoom into this a little bit. Okay, so if we look at the first one, 4x squared minus 12. So let's first just think about the 4 and the 12. So our factors of 4 are 1 and 4 and 2 and 2. And our factors of 12 are 1 and 12, 2 and 6, 3 and 4. Okay, so by looking at our two tables here, we can see that the greatest common factor is going to be 4. Okay, so that is the greatest common factor of the numbers. Okay, so 4. Now let's focus on the variables. Now remember that the x over here has an invisible 1 as its exponent, so don't forget about that. So for the variables, we always take the guy with the lower exponent as part of the GCF. So next to the 4, we're just going to stick x to the first, okay, which is the same thing as just 4x, okay? All right, so now we are going to, once that we have found the GCF, we are going to go back to the original problem. We're going to divide both of our pieces by the GCF, okay? So we've got 4x to the first and 4x to the first, okay? All right, so now, switch colors again. All right, so now for the first one, the 4s, those reduce to 1. And then remember that when we're dividing variables, we subtract our exponents. So x squared divided by x to the first, we're just going to do 2 minus 1, which is 1. So you're left with x to the first, okay? All right, now on to the second one. So 12 divided by 4 gives us 3. And now if we have x to the first over x to the first, it's the same thing top and bottom. So that actually just, I know we like to say cancels out. It really reduces to 1. But I'll let you guys say cancels out. That's fine. So this we have here, the x to the first minus 3 is what's left when we pull out our GCF, okay? So then to write the answer, we're almost there, we just have to write our GCF, which is in this case 4x. You can write to the first, you don't have to. And then in parentheses, you put what's left, x minus, 3, okay? So this last thing I put here, this guy is our answer, okay? All right, and then you can always check by distributing this back in, by multiplying it back in. So if you were to go ahead and, distribute that back in, you would get back your original problem, okay? All right, so now let's take a look at letter B. So again, I'm going to first think about, okay, do I have a GCF? So if we think about our factors of 4, we've got 1 and 4 and 2 and 2. And then with our factors of 9, we have 1 and 9 and 3 and 3. Okay? So if you look at your two lists, the only factor that they have in common is 1. So when that happens, you're not going to factor out the 1 because you would just get back the same thing. So we don't really worry about it then. So we don't have a greatest common factor other than 1. So let's move on and think about our next type of factoring, which is difference of two squares, okay? Now, if you look at this binomial that we have, its difference, we have the subtraction symbol of 2, okay, so there's two pieces, and then are these guys perfect squares? So 4 is a perfect square, x squared is a perfect square, and 9 is a perfect square. So this is going to be dots factoring, dots. Okay, so whenever we do dots factoring, it's always the same. We start off by taking the square root of the first piece. So in this case, the square root of 4x squared is going to be equal to 2 x, okay, because the square root of 4 is 2, and then the square root of x squared is just x, okay? And now we're going to take the square root of the second piece, which is 9, and we get 3. Okay, so we've done the hard part now. So now then to write the answer, it's always going to be double bubble. Okay, now since the 4x squared came first in our original problem, we're going to put the 2x, oops, we're going to put the 2x and the 2x in the front of each bubble, okay? Then the 3 goes in the back of each bubble. And then for the signs, whenever it's dots, you're always doing plus and minus. So plus and minus, okay? It doesn't matter which one, you can do minus and then plus then minus. It doesn't make a difference as long as one of them has plus and one of them has minus, okay? All right, good. All right, now on to the last part of the do now. All right, so for the last one, x squared plus 5x minus 14. It's pretty easy to see right now that this one does not have a GCF, only because if you look at the numbers, so your coefficient of your x squared is 1, and then the other numbers are 5 and 14. You're not going to have a GCF there other than 1. And then all 3 pieces don't have an x. If all of them had an x, then you'd be able to factor that out. But that's not the case. So it's definitely not GCF. Definitely not dots, because dots has to be with 2 pieces, and there's 3 here. So we're going to use the last type of factoring that we did, which is trinomial. Okay? So the goal with trinomial factoring is to find 2 numbers that are going to add to the middle term and multiply to the last term. Okay? So we're going to start off by listing our factors of 14. So 1 and 14 and 2 and 7. Okay. And then we want to look at and see, okay, which pair can give us the 5 in the middle. So that's going to be the 2 and the 7. Okay. So we're going to go over here and do our double bubble. X and X in the front, and then you're going to put 2 and 7 in the back. And now this is the hard part, is just figuring out what the signs are going to be. So I went over this yesterday, so we can go over our 4 options. It's either going to be plus 2 plus 7, plus 2 minus 7, minus 2 plus 7, or minus 2 minus 7. So plus 2 and plus 7 gives us positive 9. Plus 2 minus 7 gives us negative 5. Minus 2 plus 7 gives us positive 5. And negative 2 minus 7 gives us negative 9. Okay? So we were trying to get positive 5, which is this guy right here. So you're going to have a minus with the 2 and a plus with the 7. Okay, so this is our final answer. All right. Okay, so that's just going over the 3 types of factoring that we've done so far. So we're not learning any new type of factoring today. We're just going over what happens when you need to factor more than once. Okay, because sometimes you're going to factor one time and then there's going to be something else you'll be able to do. So when you factor completely, it involves factoring more than once. Okay? All right, so let's just scoot over here. All right, so again, the first kind of factoring we always check for no matter what is always going to be GCF. So let's take a look at number 1. So we've got 5x squared minus 125. So let's think about our factors of 5. So our factors of 5, oh, that looks like a terrible 5, hang on. So our factors of 5 are 1 and 5. And then our factors of 125 are 1 and 125, 5 and 25. And am I missing one? Hang on, I'm thinking. I don't have my calculator with me. I think 15. Hang on one second. pretty sure I'm forgetting one. Nope, I'm not. Okay. All right. So if we look at these two lists, you'll notice that the largest number that they both have is 5. Okay. And then since both of our, if you look at the original problem, if you look at the terms, only the 5 is the one that has the x. Okay, so x is not going to be a part of our GCF just because the 125 doesn't have one. So our greatest common factor here is 5. So we are now going to divide each one of our original pieces by 5. Okay, so 5x squared divided by 5. The 5's cancel out. They really reduce to 1, but I'll let you say cancels out. And that becomes x squared. Okay, minus, and then 125 divided by 5 is 25. Okay, so this is what you get when you divide the GCF out. So right now we're at this point. Hang on one second. Actually, let me just erase that. So right now, oops, we're here. I'm going to put so this is what we got when we divided the 5 out, and I just put the 5 on the outside. Okay, because it's the GCF. We just pulled it out. He didn't disappear. He just stepped outside. Okay, so now if you take a look at the x squared minus 25, okay, now if you think about this, we have a difference, we have subtraction, and x squared is a perfect square, 25 is a perfect square. So we can keep going. We can keep factoring this one more time, okay? So the square root of x squared is equal to x, and the square root of 25 is equal to 5, okay? So what you're going to do from here is just do your double bubble, okay? You're going to do x and x in the front, and then 5 and 5 in the back. And then whenever it's difference of two squares, it's 1 plus and 1 minus, okay? And then you still have to bring down that 5 from the beginning because he didn't go anywhere. Remember, he just stepped outside. He's still there, okay? So this right here is your final answer, okay? So you need to go through 2 steps to complete the factoring for a problem like this. So whenever you factor on any kind of problem, you always just want to take a minute at the end and look and see, okay, well, with what I have, is there anything else I'm capable of doing? So that's just something you always want to keep in mind, okay? All right, so let me erase my little line over here. All right, so now let's take a look at question number 2. I'm probably not going to go through all of these because you do have the answer key up on Google Classroom. So I'm just going to go through a few of them just so you guys get the gist of it. But if you have any more questions, you know that you can contact me, email, Remind101. We can do video conference, whatever works for you guys, okay? All right, so let's look at number 2. So again, we always start off by looking for a GCF. So they don't all have x's, so x is not going to be a part of the GCF. But if you look, we've got 2, 8, and 10. So 2 is going to be the GCF. That's the biggest number that can go into all 3 of those. So we're going to start off, our GCF here is 2. So we're going to divide each one of our pieces by 2. Okay, and then we're left with, so the 2's reduced to 1 over here. X squared plus 8 divided by 2 is 4. X minus, and then 10 divided by 2 is 5. Okay, so that's what we're left with when we take out the GCF. So remember, it's still there. It didn't go anywhere, just stepped outside. Okay, so now we're going to take a minute and look at what we have left and think, all right, can we keep going? So it's definitely not dots because there's 3 pieces, not 2. So let's see, can we do trinomial factoring on this? So I'm going to see if I can find 2 numbers that are going to add, hang on one second, to make 4 and multiply to make 5. So if we think about our factors of 5, we only have 1 and 5 because 5 is a prime number. And 1 and 5 can in fact come together and make 4. So I'm going to now go down here. So we've got x and x, 1 and 5. And I'm going to go to the side over here and try to figure out what my signs are going to be. So list all my options. And let's see. So plus 1 plus 5 gives us positive 6. Plus 1 minus 5 gives us negative 4. Negative 1 plus 5 equals positive 4. Negative 1 minus 5 equals negative 6. So we are looking for positive 4. So that would be this pair right here. So that's a negative and that's a positive. And just don't forget to bring down your 2. He didn't go anywhere. He just stepped outside. He's still there at the party. Don't kick him out. So this is our final answer. Okay? All right, good. All right, I definitely want to do number 3 because number 3 is a little tricky. And number 3 is actually one that I've seen a few times in the Regents exams. So this is definitely a possibility of something you could see. So looking at this right away, there's no GCF. Well, again, the GCF is just 1, so we don't worry about that. So the next thing I think about is dots. Okay, so I've got 2 pieces, right? This is difference, and they are both perfect squares. Now remember what on one of the earlier worksheets I mentioned, I think I showed you guys that when you're taking the square root of anything, that any variable that has an even exponent, you divide the exponent by 2. So for example, this is just separate. This has nothing to do with this problem. So let's say I want to take the square root of x to the 6th. That's going to be x cubed. You just divide the exponent by 2. So that's our rule that we always use. Don't worry about odd exponents for right now. I'm not going to worry about that. So we're going to, whoops, all right. Okay, so the square root of x to the 4th is x squared, and the square root of 1 is just 1. Don't forget 1 is a perfect square. All right, so now by dots, we've got x squared plus 1 and x squared minus 1. Okay, so you're looking at it and you're like, all right, this looks pretty good. It looks like we factored it. But upon closer inspection, if you look right here, we have a difference of 2 perfect squares again. Okay, now I don't care about, now this side, I just want to mention something. This side we cannot factor because you'll notice that here we have a plus sign. So that's not difference of 2 perfect squares. So this, the first guy that I just underlined in blue, can't factor that. But we are going to factor the second guy. Okay, so let's go back to that. All right, so the square root of, right over here, of x squared is x. And the square root of 1 is 1. So this guy is going to come down here and become x plus 1, x minus 1. And then, let me just erase this so I have a little bit more room. And then we have to still remember to bring down this guy from, he's still there. He didn't go anywhere. Got to make sure to attach him, okay? So this is our final answer right there, okay? So we ended up having to do dots twice on this one, okay? All right, good, okay. So let's take a look now at question number 4. I'm just looking what else is on the sheet. Okay, all right, so let's look at number 4. All right, so again, the first thing we always want to check for is, do we have a GCF? So x is definitely not a part of it because we don't have x's in both pieces, but if you think about the 2 and the 50, so our factors of 2 are 1 and 2, and our factors of 50 are 1 and 50, 2 and 25, and 5 and 10, okay? So your greatest common factor is 2, okay? So I'm going to divide both of my pieces here by 2, my GCF. So GCF is equal to 2. Okay, so then what I'm left with is x squared because the 2's cancel out. They really reduce to 1, but I'll let you say cancels out. Minus, and then 50 divided by 2 is 25. Okay? And remember, the 2 didn't go anywhere, just stepped outside, so we have to remember to bring that 2 down. Okay? All right, so now I'm looking at what I have inside. I'm looking at the x squared minus 25, and that is going to be, I'm giving you a chance to think, and I'm waiting for someone to call out. Yes, that's going to be dots. Very good. Okay, so we have a difference of 2 perfect squares. All right, so our square root, I'll do this over here, of x squared is x, and the square root of 25 is 5. Okay, so this part becomes x plus 5 and x minus 5. Okay, and again, don't forget, bring down that 2. We didn't go anywhere. Okay, so this right here is your final answer. Okay, all right. Let me see what other ones how about we go over maybe one more, and then I think you guys can look at the remaining ones on your own, because I do have the answer key up. But again, if there's anything that you're having any trouble on, just shoot me a remind, send me an email, whatever works, and we will go over it. All right, why don't we let's do number 6 on this page. Whoops, okay. All right, so now number 6. So again, the first thing we always want to check for is GCF. So actually, before we even do that, I'm going to add in my little invisible 1 exponent. That does not look like an exponent. Hang on one second. Okay. Oops. Oh, this is not what I want. Okay. All right. Add that in a little bit. All right. That's a 1. Okay. So if you look at our 2 pieces, if you look at the x's for the GCF, we take the lower exponent, which in this case is 1, so x to the first. Now, since only the first term has the y squared and the second term does not have the y squared, y is not going to be a part of our GCF. Okay, so it's only going to be the x to the first. So now what we're going to do is divide each piece by x to the first. Okay, so when we do that, in the first term, the x to the firsts reduce to 1 or cancel out. All right, so we're left with y squared minus, okay, and then x cubed divided by x to the first. So remember, when we're dividing, we subtract our exponents, so we get x squared, okay? And don't forget, you've got to bring your GCF down. So remember, we took out the x, okay? He didn't go away, he just stepped outside. All right? Okay, so now let's take a look at the y squared minus x squared. So again, we've got 2 terms, we've got subtraction going on. Both of these guys are perfect squares, so now we're going to be doing dots. Okay, so the square root of y squared is equal to y, and the square root of x squared is equal to x. So now this part here, when I do my double bubble, the y's go in the front because the y squared was first, and the x's go in the back, 1 plus and 1 minus. And don't forget to bring down your original x from the beginning of the problem. Okay, so then this right here is our final answer. Okay, so this is the gist of what you're doing when you're factoring completely. There is a second page to this worksheet. I have it posted on Google Classroom with the answer key, but if you're going through it and there's anything here that you're confused about, please reach out to me and we will go over it, and I will do my absolute best to make sure that you understand what we are doing. I'm going to be posting an assignment on Google Classroom tomorrow, which will be due Thursday, and that is it. So I hope everybody's good. I miss you guys, and we will talk soon. Bye.